Thank you, everyone, for coming to my talk on getting value out of chat data. Yeah. All right, I'm Daniel Shank. I'm a data scientist at Talla. You can contact me at my email address here. I prefer that as opposed to any other sort of social media channels. That's good. Talla is a company that works using NLP for internal business use cases. So I'm actually going to be going over some similar stuff in terms of natural language understanding that you just saw, but we assume usually much smaller data and data that's particular to a particular company, and it's not necessarily public. We're also working on a platform for doing smart knowledge management, which looks a little bit more like a wiki sort of situation where you can query it. The system will learn to generate answers for your query much better, and you can sort of annotate it as you go when you insert new answers. All right, so just to kind of ground what I'm talking about, and you don't need to read the text as it is at this line, like just to give you an idea, like we're talking about chat data, so this looks like a bunch of people sitting around in a chat room talking to each other. There are usually the user tags as well as timestamps. And so it can also be similar to things like comments on a forum board, other sorts of sequential interactions, some sorts of email interactions. Usually in order, we have time, we know the users, we can frequently see them directed at particular users, and they're often, as you might imagine, frequently very context dependent. So there's a couple of problems with the chat. In spite of the fact that it's become more and more dominant as a medium of exchange in the business world, like we're seeing Slack, we're seeing HipChat, a lot of Microsoft Teams usage, and we have like lots and lots of information there. In theory, you could just read the logs and get practically any piece of information you wanted about a company, but in practice, this is totally unlabeled, so it's actually not as helpful as you might expect. And we'd like to be able to get more value out of this data. We frequently have like lots of chat logs sitting around, and there's a question of like, what do you actually do with these? All right, so there's a main goal that I'm going to be focusing on. There are lots of things you could do, but the thing that my company is most interested in doing is finding issues and matching them to incoming questions. So you see someone asks a question, you say, like, for instance, what's Patriots Day? This frequently comes up in Massachusetts, such as a state-specific holiday, and people don't know what's going on, and you want to say, like, oh yeah, sure, we do get it off. It's an important holiday. And then another user asks this question. And you see a lot of redundancy like this, and we'd like to be able to minimize this to the point that we can recognize when a repeat question is asked and serve the answer without needing to go through a human. Okay. Yeah, so the general flow of what our aim is to like find issues or questions that people have asked in the past and match them to new incoming questions. Find some sort of answers, serve it up to people. Excuse me. Yeah, I'm not going to talk about actually extracting answers. That's a difficult, very interesting problem, but I'm mostly leaving that on the table here. I'm going to focus primarily on getting as much mileage as possible, matching new incoming queries. So there's going to be three general thrusts to what I'm going to talk about here. So the first one you just saw before a few minutes ago, I'll go into a little bit more detail if I can, is active learning, which is a way of getting more value out of data that you have when you're annotating it yourself or working with crowd workers. All right, so the first thing I'm going to start with is finding questions in your data set. So this is a pretty easy thing to do. You can be mostly relying on the fact that things have question words or question marks in them, and so you can pull them out. And the idea is that you start with this as your basis for like problems that people have had in the past. If someone asks a question and you want to get some sort of answer out of it, it's not too difficult. It seems like a good place to start. But the problem is that unlike the things that I've just shown you, it turns out most questions people ask aren't simple form questions that are understandable by themselves. So, like, people don't frequently ask things like, how do I get blah off, or what is X? And they usually, like make it context dependent. So in addition to that, not only may not be able to understand a question out of context, they also have different intents. Not all questions are requests for information. Turns out if you actually examine what people are talking about, a lot of questions actually have to deal with, for instance, like getting someone to do something for you or even just expressing simple confusion, which isn't easily resolvable. All right, so as an example of the sort of problem that you're going to run into are questions that have demonstrative phrases like it and that, things that are called anaphora generally. So there are ways to resolve these, which also I'm not going to discuss here, but the general idea is that these are questions that do map to some sort of question that you think you could answer if you had the context, but that it isn't necessarily easy. There are also questions where it may be understandable, arguably, but the answer is dependent on the time or some other variable. So for instance, you can say, what day is it today? And you would say, oh, well, that's actually totally understandable, but the problem is that you need a more complicated data model to deal with it. So you have to be aware of questions that are dependent on some sort of external variable. So questions have a couple of different intents. So we went with an ontology that's related to an ontology people have used for search for a long time, which is basically, are people looking for a piece of information? Are they trying to get to something? And what we sort of interpreted that as, are they looking for instructions? Or are they trying to get someone to do something for them? Are they asking for a service? So this is a sort of classification problem that we found and decided was important to going forward with making use of people's questions. And so there's a question of if we can write special case rules for this. And it seems like you might be able to, but in practice it turns out that people aren't clear about the sort of things they're saying about. So things are frequently phrased as, can you do this for me? And if you answer someone who asks you if you can help them with something by saying yes, full stop, that's usually not an acceptable response. But the fact of the matter is that's how people ask for things. They also ask people to give them answers to stuff. And if you look at these and parse them directly, you might think that they're asking someone to do something for you, whereas they don't actually care if a person does it for them. They just want the answer, and they'd be totally happy if you gave them the information that they wanted. So you could write special rules, but in practice there's a lot of these. I won't say it's impossible, but we decided to go with a supervised learning approach, but it means that you actually need labels. And getting labels can be annoying. I mean, it can be difficult, it can take a lot of your time. More specifically to this problem, it's hard when you can't really anonymize your data successfully and still have it be interpretable. If you're using, for instance, someone's internal chat data, it's very hard to just source it out to a bunch of crowd workers. That might be possible if you have very good pre-processing, but as is, it's a lot of problem. And even so, once you've done this, you want some guarantee that your model is actually going to work when you're done. So you can put all this work in and then find at the end of the day that it's a problem where there's not enough signal for you to work with. So you want something that's quick and can make the most of your time. And so we went with something called active learning, which you guys saw a couple of minutes ago. The general idea is that it's a human-in-the-loop method where you have some small pre-annotated or labeled set of data that you then train a model on. You use the predictions or the uncertainty to choose the new labels. There are a couple of different strategies for this. And you use that determination to decide what to label next. So you just go through this iterative process a couple of times, and it's a good way of getting a classifier up to speed quickly. So as an example, like, again, sorry about the equations, guys. So as an example, what happened for us was that we started with a very small, I think it was even like 100 data points, right? We wanted to annotate some simple method of intent, like is someone asking for a service or asking someone to do something for them? And we go through, we label these up, we train a very simple model. We go through and we predict on all of our unlabeled data, and then once we look at that and we decide what to do. And a common method is simply to look for questions that are closer to 0.5 or you have the lowest confidence score so that you have the most expected change in your model. So we iterated this a couple of times and we got to a point where the classifier was actually performing fairly well. Now there's an important warning here, which is that if you do this sort of process, and it does depend on your strategy, you may lose a lot of assumptions that you typically make about your data set. So for instance, the class label distribution may not, unless you take specific pains, adhere to what you're used to, right? Like it's not going to be just a random sample from your data set. It's actually going to depend on whatever process or strategy you're using to select new data. But if all you really care about is getting a good decision boundary quickly, or even just performing a ranking problem, this is actually a pretty good idea. Yeah. All right, so I'm going to take a small digression and talk a little bit about topic modeling. And I think there's a good reason for this, though, which is that when you're working with data like this, it's important to figure out what's actually going on. I mean, chat data is all very different. I mean, it's very specific to the sorts of things that people are talking about. So it can be critical to understand, like, what are people's key issues. And also when you're trying to develop a product based on this sort of thing, you have to figure out, like, what would even be possible based on the data that you can find. And so the general flow is that you want to read your data if you can, or generally you can't read all of it, or you're usually allowed to read some of it. I mean, you learn the context. I mean, it's remarkable how many conversations you can read, and if you still don't know like what the company does or like who these people are, you have no clue what they're talking about, even though you have pages of text. And then as a way to get, once you've done those things, as a way to get a general idea of what sorts of things they're actually talking about overall, you can use a clustering method. And clustering methods are actually difficult to use. In general, not just, and some also for the specific problem. So human supervision is necessary if you actually want to interpret what they're doing. Clustering algorithms are not magic topic finding machines. Topics that come out don't necessarily mean anything. They are statistically relevant. but they're dependent on both the number of topics you choose and any number of parameters you want. So if you want to actually pick a good set of clusters that make sense for your data, you have to actually interpret them. You have to actually try the algorithm with multiple parameters and then decide what you're going to do. An interesting thing that you'll notice if you're trying to understand what sort of utterances you're dealing with here, so single message documents, you're going to find that things tend to have a less broad topic distribution. For a longer piece of text, even a paragraph or a book, I mean, you can expect things to have multiple categories that they belong to or be more likely to be on the fence, but for a lot of messages, things are simply about one thing. If someone sends a message that says, I'm working from home, there's really only one intent that you can get out of that. I mean, maybe you could break it down a little bit more, but generally that's the story that you have to deal with. And just as an example of how your parameters could be important and you really have to interpret these things, I have an LDA model here that I've just gone through and tweaked the concentration parameter, alpha, which is essentially an assumption about how clumped your probabilities are going to be. So for a lower alpha, you expect probability distributions to be highly peaked around a couple of different things. And the thing I'm trying to demonstrate here by showing you these topics here, in each column we have one run of the algorithm, is just that though a lot of words show up in one topic or another a couple of different times, they get lumped together in different ways, so that even though you've chosen a particular number, small changes to this parameter, fairly large changes, can actually lead to very different stories about what your data is actually doing or actually telling you. All right. So now moving on to something, just talking about dimensionality reductions and representations. You guys have seen a couple of examples today of different sort of vectorization schemes, generally taking inspiration from Word2Vec. And the same idea applies here. Whereas we want to do something that can improve our matching method for questions that people have had in the past. And generally, this is a good idea to do when you're using NLP. You always want to use some dimensionality reduction. I mean, it's basically necessary at this point. So messages in NLP tend to be very sparse, or documents tend to be very sparse. There's a very large vocabulary in any given language, and generally you don't see all of those words in a document, which means that you're going to have a lot of zeros. But chat data is almost worse, because at the individual level, you very likely have 1, 2 words. I mean, these things are like super quick, send off, couple of messages a second. I mean, it's hard to get any meaning out of them. So that means that if you aren't careful about choosing what your context is, or like choosing your representation correctly, then it's going to be very hard to get meaningful associations between words and topics in your data. Also, as a note, it's actually quite good to use distributions that were representations that were trained in other data. It's generally a good practice, but you can usually do a little bit better if you combine them with representations that are specific to your model. All right, so the general thing the takeaway I want from here is that you can choose any variety of methods for coming up with representations for your data. Like you can use Word2Vec. I mean, that actually works quite well. I mean, but there's also a lot of methods that are essentially matrix factorization based. And when it comes right down to it, these methods are really just factorizing a term context matrix. And I say these things are equivalent with an asterisk because that means with some assumptions, these methods are more or less the same. But an important decision when you do these things, when you use these models, is deciding what your context is. So if you say, for instance, you're trying to say, like, I have a variety of words and I want them to be shown to be similar, what context they occur in can be highly variable. For instance, if I want words to be similar, if they occur in the same sentence, that's fine. But in this case, we actually care about finding words that are going to be related to a problem, particularly a technical problem that someone may have had in the past. And so I kind of talked a little bit about this already. So one solution for this is to use a time-based window running up to a question. So this is basically going to train some representations. You could do this with Word2Vec. We used a matrix factorization model that's heavily biasing words to be similar if they occur in a problem that someone has, right? So I mean, like we say, okay, people are going to state something about their problem. They say this isn't working, this also isn't working, and then what do I do? And then they ask a question. And so we're hoping that words that come out of this are going to be a great deal more similar. And then you'll see like a lot more correlation between words that will help search. So you take from that context window, you pull out words based on your processing step. And then you get something that looks like this. So you can see, for instance, for printer, we don't just find different sorts of printer models, we actually come away with things that are related when you're trying to fix your printer. So we find settings, sequences, like defaults and drivers are things that are related when you're trying to fix a printer. We see similar correlations across the board with different representations. You have 3 examples here. Yeah. All right, so I have some final thoughts on this. I think this is really just the tip of the iceberg. I mean, there's a lot you can do with this. There's a lot you could do with more data, but the problem is that for a lot of chat data, it doesn't correlate very well with other sorts of chat data. So you see a lot of internal logs that are specific to a company or to just a single group of people or an organization, and you want to be able to get meaning out of this sort of thing, and that it's difficult to take techniques that were trained on a much larger corpus and apply them to this sort of thing. So there's a real question about whether or not it's possible to learn something about conversation or informal contexts as a whole and train some sort of system that could actually learn to do better on these kinds of things. There's also a question about what sorts of information is it even going to be possible to extract. We make a sort of assumptions about, as humans, like we can understand this sort of text, but is it ever going to be possible for us to simply pull out basic facts on this sort of thing? I think it probably is, but it just requires a lot more work. But unfortunately, right now, the only way to get there is to use a lot of data, and these data sets are a lot smaller than we would like. All right, so thanks, everyone. This is generally things that we found. People say this a lot. So I will also add that we are hiring, and I added some questions in for time in for questions, I think.